Okay, we are live now. So greetings everyone. You have joined the event being hosted by the Santa Clara Valley chapter of the IEEE Computational Intelligence Society and a number of other IEEE chapters in the country. I am Vishnu Pendyala, the chapter chair. We hold a unique position due to our strategic location and the wealth of expertise available to us. So today we have a distinguished speaker talk to us on generic large language models in cybersecurity. Um, so generic large language models are continuously being released with increased size and capabilities, promoting the abilities of these tools as universal problem solvers. While the reliability of GLLMs, which are generic large language models, their responses is questionable in many situations. These are augmented or retrofitted with external resources for different applications, including cybersecurity. So today's talk will discuss major security concerns of these pre-trained models. First, GLLMs are prone to adversarial manipulation, such as model poisoning, reverse engineering, and side channel cyber attacks. Second, the security issues related to LLM-generated codes using open source libraries, codelets, for software development can involve software supply chain attacks. So these may result in information disclosure, access to restricted resources, privilege escalation, and complete systems takeover. So this talk will also cover the benefits and risks of using GLLMs in cybersecurity, particularly in malware detection, log analysis, intrusion detection, and so on. The speaker will highlight the need for diverse artificial intelligence approaches from non-LLM based smaller models trained with application-specific curated data, fine-tuned for well-tested security functionalities in identifying and mitigating emerging cyber threats, including zero-day attacks. So today's speaker is a distinguished lecturer with the Computational Intelligence Society. He is a professor. Dr. Dipankar Dasgupta is a professor of computer science at the University of Memphis since January 1997. Professor Dasgupta has extensively worked on the applications of bio-inspired and machine learning approaches to cyber defense. His groundbreaking works, including digital immunity, negative authentication, cloud insurance model, and auth spectrum, have earned recognition in Computer World magazine and other media outlets. Um, Professor Dasgupta received research funding from different federal agencies, including NSF, DARPA, IARPA, NSA, Navy, the ONR, Department of Defense, DHS, FEMA, and so on. At the National Cyber Leap Year Summit in 2009, Dr. Dasgupta served as a co-chair for the Health Inspired Network Defense Working Group, the results of which have led to a new research program within the Department of Homeland Security's Science and Technology. With over 300 publications, including 4 patents, 22,000, more than 22,000 citations, and an H-index of 68, Dr. Dasgupta's multidisciplinary research is highly acclaimed. He has received numerous awards, including the 2012 Willard R. Sparks Eminent Faculty Award and the 2014 ACM SIG EVO Impact Award. Dr. Dasgupta also received 5 Best Paper Awards in different international conferences and has organized symposia on computational intelligence in cybersecurity at IEEE SSCI during 2007 to 2023. That's a lot of years. Dr. Dasgupta is an IEEE Fellow, AIIA Fellow, and NAI Fellow. an ACM distinguished speaker from 2015 to 2020. He is, of course, an IEEE distinguished lecturer and 2024 NSF Fulbright distinguished scholar. He regularly serves as a panelist and a keynote speaker and offers tutorials in leading computer science and conferences, and has given more than 350 invited talks in different universities and industries. So with that small introduction, over to you, Professor Dasgupta.
Again, thank you, everybody. Good evening in some places, and other places maybe in other time zone. Sorry for little hiccup because our university now use Microsoft Teams and Zoom, kind of a foreign entity, so it took a little while to go to set up everything. And I'm assuming, Vishnu, my voice is clear?
Yes, voice is clear,
Okay, great.
it's all clear. Yes.
So I'll start with the introduction, but the moderator already covered a lot about me, but I'll just quickly go through the slides. But my focus will be AI/ML and generative generic large language model and their security challenges, how LLMs are used in cyber defense and including tools. AIs are always dual purpose, sometimes offensive, sometimes defensive. So that's a good lesson to learn. And now this is my, credibility of 30 years of research in AI ML algorithm and a wide variety of applications. Though from 2000, I'm mostly devoting my time in cyber defense. So with that, these are some of my books. New book is coming out on generative AI, model and application in 2025. So these are patents, some are under submissions. And as the moderator mentioned, I also organized computational intelligence in cybersecurity for more than 20 years. I was also co-chaired DHS National Cyber Olympiad. Now, to start with the AI journey, I'd like to emphasize to researchers, scholars, and applicators that there are many AI/ML techniques. More than 50 so-called computational intelligence. We used to call computational intelligence under that all different AI/ML techniques and heuristics. Some are model-based, some are data-driven, rely on data quantity, quality, and the how clean the data is. Learning model varies from all different ways. So also, to be technically correct, AI is not equal ML. All are algorithms. Under that algorithm, AI, then under subset is ML, then neural network, and many other branches. While you come to the application, there are narrow AI application and general AI applications. So you can see there are whole different types of algorithms, and you can see many different charts developed by many different people. But what I'm trying to say, neural network is not the only AI algorithm, though the companies or the big techs are moving because it can be, as a big box, can be used as a problem solver. But as I always say, the AI is not magic, it is computational logic. Search and optimizations are fundamental to all AI algorithms. AI algorithms use similarity measures, approximation, pattern matching to provide guided search in representation or problem space. They're mostly probabilistic and stochastic in nature. Their performance largely depends on the fine-tuning of control parameters. that is mapping function, encoding schemes, distance measures, recognition. Now, at this point, I like to mention that there are significant benefit of uh, large language models. There are companies and startups are promoting that in a big way. So my focus is not the benefits. My focus is on the where we should address, how we'll use these models for safety critical applications, in particularly the cybersecurity domain. So as I move forward, and many of my uh, thought processes may not concur with the traditional thoughts, the way the technology is moving, but I think it is worth listen to. I am ready to get any feedback, any comments, any criticism. I'll welcome all those kind of things. So generative pre-trained models primarily currently use deep neural networks become industry preferred for multimodal large language models. So you put various types of inputs and that is trained, and then some kind of vector or knowledge graph, you store that knowledge and then use it for retrieval. These are some of the multimodal companies and the type of businesses they started with. So, and you will see the more and more companies my guess is every week a new company will pop up for different purpose, better and better solution providing. So why that was possible in last 40, 50 years, that was not possible. You can see the things are getting bigger and bigger. It seems there is a competition for getting how big you can go. And that was possible because increased computational power and digital storage are making all these AI ML systems success in large scale universal applications. So you can see GPT-4 has 1.8 trillion parameters, Gork has 2.7 trillion, and list goes on. So it seems the increasing size as a universal problem solver, that is one of the direction that is going. But you'll see later on also things are going in a reverse direction, and why, we'll talk about that. So what happened is this, all this generic, that's what I put the word generic, these models, and then there are different plugins, applicators, they are used for different applications. But as we all know, 60%, 70% accuracy is the current norm, and it hallucinates if there is a context change. So there are a lot of fixation to avoid that because they are not fine-tuned, they are general purpose, and it is a storehouse of all the information. So the global data collection and removal of metadata, of course, now those are coming back. You can get some references, and many a times those references are not accurate, violate privacy, copyright, and all these issues slowly is getting resolved. So, so you can see things like RAG, retrieval augmented generation, and others are coming as a to support this, to use these giant uh, models for different purposes. Now, these are well and good for all general applications. There is nothing wrong I can see, but can that be applicable in safety critical areas and many other areas also? I'm going to get to that. So RAG came as a huge different modification as to support or to enhance the performance of large language models, in particular generic large language models. So in one example, you can see the questions are generated, created by the user, and then embedding, and then it goes to a vector. So ultimately, prompts are coming as an answer. So the documents are summarized many different applications you can see here. And it able to filter, obfuscate unwanted bias, toxic, and unethical LLM responses. Then LangChain is another framework came with a broader aspects where you can also use agents on top of the LLMs and many other functionalities, and many people use that. So if I put everything together, what I'm seeing is like this, that retrofitting generalized LLMs for applications. There are external data is been because you cannot get the information after the uh, training is complete. So to that, you have to connect to the search engine, you have to connect to the crawler to get the up-to-date information. LangChain, then the prompt engineering become a big area. And those who are continuously learning prompt, as new model will release, some modifications of prompt will have to be there. So chain of thoughts, uh, thread of thoughts, different types of uh, mechanisms are coming to get more appropriate result. And the other side, this MCP is also become very important, that model context protocol. And the argument is model context protocol may serve better when you combine many documents because it takes care of the context. Then some people argue whether RAG will be replaced by cache augmented generation or knowledge augmented generation. In other words, you have some knowledge and that will augment your search. And also in the response areas, there are filtering and reinforcement learning from human feedback. So that's the reality. You need to have some baggage with the generic LLM to get something good out of it. And it cost varies for different types of load. So you can see cost overview of retrofitting methods for LLMs, from the least expensive, that prompt engineering, function calling, tokenizer extension, and then most expensive is the fine-tuning the results, or reinforcement learning with the human feedback. So there are other in between that needed to get the generic large language models to work for your applications. Then the question comes, and these questions are very essential for everybody, researchers, scholars, applicators, adapters. Can it possible to develop generic large as a universal problem solvers? That's the important thing. So is the bigger is the better for specific applications? What percentage of response are provided by language model or by other things? There is no publication I have not seen, and I'll be looking for if anybody can put in the chat that there is some work that shows 60% of the output is provided by LLM and 40% by these external bags or external data sets. Can language-based GPTs, generative pre-trained model, avoid hallucination, ambiguity, and inaccuracies? In many safety critical cases, we need 99% accuracy. So is the language is the best way to train those things, particularly in IoTs and all other, where machine to machine is talking? Where is the language comes from? Can it possible to perform independent evaluation of generic large language model because we don't know the scope and the data coverage? Is black box testing be effective without knowing the large language model scope and data coverage? These are the important things for government or any big agencies for acquisition and adoption of these tools and techniques. So as they bigger and bigger realizing they are becoming more expensive, it cannot be used in uh, smaller area, it doesn't serve the purpose with all this hallucination. So different types of truncation, precision minimization, so smaller models are coming up, and you can see there is a list of top 15 uh, tools that can be used now and considered as smaller. But they move down from trillion to billion, and some are in millions. So for different applications. So it is bound to go down to a smaller model because the large model are not sustainable in critical application or any applications of user need. They are good for different other purposes, but not for application which are of high importance. So, and my hunch is that as people will start building their own model, so it will, as you will see more and more, it will democratize the AI applications. There will be many startups, and they will build their own model. They're not difficult to build from scratch, and application specific that can guarantee the scope, can be nicely evaluated, and also can be accountable for anything wrong. So this is about the models. Now let us look into the security challenges. Security challenges of, particularly from the software, because all are software security and adversarial AI perspective. So let's move on to that. You can see there are two security issues. One is the large language model software itself. Another is a LLM generated code. Now, you can see studies after study that the cybersecurity risk, adversarial attack, because these are pre-trained, static. So, given enough time, they are breakable. They can be, so looking at even millions of input and output analysis, it may be possible to uh, contaminate these models. And then the model itself can be poisoned because these are vector spaces, and manipulation of weights also can be um, change the outcome. So there is a device called zero-click worm to manipulate ChatGPT 4 and Google Gemini to use it as an worm or spread spam to thousands connected users. So again, security flaw can also contaminate. So these are all related to software, because AI is addition to what regular software is, but this is a software, and all that needed security precautions also applicable to AI softwares. So, and again, software bill of material regulations and all this will help to make this uh, uh, LLM secure. There are debates on whether open or closed source AI be needed. So there are a number of arguments for and against, because accountability and misuse of open source AI technologies also be critical for countries' safety and security. Now, you can see the implications of security, misuse examples, vulnerable examples. So that's the security and safety overlaps. Then high impact domain like healthcare, finance, you have to make sure, because AI is a software, that software security lifecycle and software security things are maintained. And there are, because we don't know the opaqueness of the model, its inner functionalities are not known. So black box models always this factor. Yes. So is somebody asking question? I will keep some time for questions at the end of my talk, unless there is somebody who wants to ask a question now. So you can see in October 21st that Microsoft Copilot, because there is an interface to the external entities, so they were able to manipulate the Copilot, and they called it confused pilot. That means it was a data poisoning attack and produce wrong outcome with that manipulation. There are number of LLM issues that OWASP listed, and many of you know that prompt injection and all these others are all software security risks, are also very dominant on the AI software. So and there are a number of defense strategies to make sure these LLMs are secure. So, for example, watermarking and logging, LLM activities, then again, reinforcement learning with the human feedback. So make sure that things are not and other prompt filtering, block list, and list goes on. And also AI with a red teaming. But again, that's teaming we limited to black box testing. Now, that was the software aspect. Now, LLM also can generate codes, and that code also can use for other purposes. So there are two aspects. One is the LLM's software itself, and the LLM generated code, so like Codex or Autopilot. They use mostly um, open source libraries, functionalities, and that we all know open source has security issues. So these are number of companies who are there. You can use them to generate code for specific applications. So, and list is continuously growing. And again, the disclaimer is this lecture is for educational purpose, and credit should goes to all the people working in the field, and the material that I am using to put my lectures together and for and against my justification. So you can see a number of generators. Now, with the increased geopolitical situation, software supply chain attacks, and last few years, all of us know SolarWind, Log4j, MoveIt, and list goes on, become a major security issues. Then question is, this LLMs for auto-coding tools using open source libraries reported to have many vulnerabilities, are too risky. So also regulations are coming to enforcing this software bill of material for securing IT products and services, like commercial off the shelf or government off the shelf. So sooner you'll see that source and identity of code development process need to be disclosed and attributed. So this was a old slide I modified recently because my timeline need to be adjusted. So I feel sooner and when that will come, trusted closed source development with attestation will be the future trend of secure software. So auto-generated code, and recent report I was seeing 60 to 80% of the coders are using some of the auto-generated code as a first phase. But if they don't understand the second phase logic, then that will be the code. So you can see when OpenAI released ChatGPT in 2022, the open source codes, and my hunch is that as we go along in 2027, the more third-party attributed code generation have to come. And if geopolitical situation get worse, trusted closed source code need to be accepted for any safety critical operations. So in other words, we need to know who has written, when it was written, by whom, or by which organization. So anonymous concept and may not be there because good people also do sometimes bad thing, and that can cause big damages. And with more and more nation states are involved now in cyberspace, because cyber is now our first life and it has everything on it. So if things need to be more tightened, trusted closed loop software source code need to be designed and developed for safe operation of the internet. Now, next on my topic is there are number of companies are now using this LLM-based tools for cyber defense. And here, my argument will be, if I don't know what is inside, if I don't know what is inside, if I cannot give accountability of everything to somebody, to regulator, to evaluator, third-party evaluator, is it appropriate for cyber defense? Now, next thing is, are language models appropriate in cyber defense? You can do it for operator communication, but when machine to machine talking, collecting the sensory information, processing it, where is the language come from? So language tokens are not applicable here. What we need is a data token. What we need is a data stream. So yes, some model use data stream, but they still label it as a LLM, which is a misnomer. And I'll show in my last slide, there are so many misnomers in tech community that need to be corrected for scientific betterment. So with this increased cyberspace and emerging technologies, you can see the attack surfaces are also increased. These large language models are also vulnerable and may be attacked because they are pre-trained, pre-generated, static. So that's one of the diverse data sources also can be manipulated. Then also Internet of Things, communication media. Now you can see communication media is going to be a big challenge for the cybersecurity perspective because they more and more everything will be wireless. So cellular, then low orbit satellites are now serve as an internet, and so air gap attacks becoming more prominent because you don't need anything to do that kind of attacks. And there are few initial research shows that it is possible, even if someone is not connected, can launch an attack because we are in the unguided communication space. So, and we may argue that encryption encryption is there, but encryption is as good as we can think. You will see encryption also has broken in many cases and will be broken in coming days with quantum computing and for many other reasons. So, so these are as the technology is coming, both in the communication, so attack surfaces are also increasing. But the interesting thing is, entire computing world is in two dilemma, and these are the dilemma I'm talking about. That we are taught that everything need to be standardized, standard operating system, so that homogeneity is important, then wide usability. But for the security purpose, we have to obfuscate. Then message and information sharing. For good purpose, we share information, we share message. But from the security aspect, we have to have information hiding. We have to have confidentiality. We have to have encryption of strong encryption. But now the devices are small, so lightweight encryptions are used. So there are many challenges. Software lifecycle, we were taught that the software, like you have to have a standard naming procedure, you have to have steps. But from the security perspective, that code needs to be obfuscated. Code need to be obfuscated so that the hackers or bad guys cannot do reverse engineering and know the code functionality. We also have the public website, which stands for providing the service. But we are not sure if the person connected is a bad guy or good guy. So we have this honeypot concept. So if there is any suspicion, it have to be diverted to honeypot or honeynet. Then we have this client-server model, which is well established and serving the cyber community, but servers are always prone to attack by denial of service attack, all kinds of attacks. Then moving target defense has been came, so that where the target, whether it's a server, whether it's a application, is moving. So you can see there is always for safety and security, the definitions are different. Then we have the application ports. For example, port 80 and port 25, port 21. These are for specific applications. There are many other application ports, but ports are remapped so that the port scanning tools cannot identify which port is running. And then we started, we have encryption. Now encryption is everywhere. Every layer of TCP/IP protocol, there is an encryption. And then storing the data, there is an encryption. When data is in motion, sending from one to another person, there is an encryption. Then during execution also now, data need to be encrypted. That's called homomorphic encryptions are used in these purposes. But again, encryption is good as you can think. One, if there is any theoretician or strong computer science theory background, we are going from one binary space to another binary space. And binaries has inherent limitations. If you think from that perspective, the breaking the encryption may not be that far. Only the length of the key is protecting the good people, but bad people are far away in breaking the encryption. Also, when we are doing all these things, we need backdoors for good reason required to in protection for forensics. For example, iPhone with 10 false attempt to open, it will be locked. But there are tools out there it can be unlocked by using. So there is nothing impossible. Only thing is who wants to do what. So you can see this is an interesting thing that which required a lot of thought process, and it's static pre-trained models are not able to handle this. Then my next thing is what LLM is coming up with lot of cyber defense. So LLMs for security, you can see you can find tools for threat detection and intelligence, right? Functions are detect malicious logs, and list goes on. And then I think I'm running out time a little bit, so I'll go a little faster. So you can see the different report generation and all kinds of applications of LLMs. Here is an example, the Gemini-based defense architecture, where LLM agents are used monitoring the environment and then uh, producing this kind of outputs. So using exfiltration that is based on this using different LLMs for spear phishing, SQL injection, DDoS attacks, zero-day attack, they are trying to address this. And there are scoring systems that scores how good that LLM is performing and producing. Agentic AI is used for intrusion detection. Again, the idea is that this is there, then you have other things that will help. But again, my question remains, how much the LLM is doing, how much other components are doing, that is then the question, do we need LLM? And I'll show that last 20-25 years, we worked on different security agents architecture, mobile agents, the immune agents, and we did a lot of projects, but computational power was not that enough as it now. So we had, you can say, 2004 security console for monitoring and response, security agents for network traffic analysis, and they did not use LLMs. They are standalone code, application specific, small enough that you can analyze. You can give your code for third-party evaluation, independent evaluation, and this is how multiple decision support can take the decision, because AI models are probabilistic. You need some decision to have a more solid output, so the bidding system can give you sometime use fuzzy controller, domain knowledge, or other classified systems. And that's how the non-LLM security agents were used for cybersecurity. So again, my question come back that we need data-driven non-LLM AI models for autonomous system purpose, where no human is involved. The environment is monitored by stream of data, and the data-driven models will communicate and give decisions. But language wrapping can be for the operator or user to work. And there is a wide variety of applications that can uh, be needed for this kind of models, where you can industrial IoTs, healthcare, wearables, smart homes, and you need secure AI systems. So, uh, so, uh, so, and next part is I'll take 2 minutes here and another 2 minutes to wrap it up. Now, if I say my AI model is using for defensive purpose, and AIs are used for both offensive and defensive. It is not that someone can only use for offensive or defensive, others will not use. They are equally powerful doing good or doing bad. So that aspect need to be, again, our language models are appropriate for cybersecurity applications. So we did long back this kind of attacker-defender game, a Navy project, evolving strategies, where neural network was not used, where the strategies will be evolved as the action attacker-defender game changes. And so now, again, for model evaluation, you need explanation as far as NIST, meaningful. And though there are a number of companies doing their own evaluation, this is the Chief Digital and Artificial Intelligence Office of US government. They are looking for quality data governance, insightful analytic metric. How do you do analytic if you don't know what is inside? Assurance and responsible AI. So I will now move towards my end slide because of the time constraint. Here is what I like to highlight. LLM-based evaluation recently, Google did some analysis of their Gemini, where the APT's advanced persistent threats at different level. They analyzed how Gemini were able to find attacks from which are APT attacks. So, but you can see the attacker and defender is continuously evolving. Both criminal and state-sponsored threat actors continuously professionalize operations and program. Offensive cyber capabilities are now the top geopolitical priority of most governments. Threat actors tactic now regularly evade standard controls. So I'm illustrating this is how we should move forward. Let's see the APT case. So we know APT has reconnaissance, malware install, lateral movement, command and control to install key, and sometimes they will exfiltrate data, destroy data, ask ransom. So different chain of activities can evolve, and the attacker continuously checking, can we install the malware in this server or in this machine? And they're using different AI techniques. They're where from one machine compromise, they go to other key servers using different AI techniques. Then command and control, how to generate key, what kind of encryption will be used, how to communicate with command and control. So they use this adversarial use of different AI tools for launching APT attack. This is an illustration. It can be any other attack. So we should not be naive that we only have this part that will protect using AI, we protect different levels, but we need a diverse AI tools, not a pre-trained generative models, which are very expensive to train again. Then we don't know what is inside. Then I put extra baggage to make it work. That's not a good cybersecurity tool. So we need diverse AI-based security where different kinds of deep learning model, fuzzy logic, and people have done this kind of work. They are not plug and play. There is a fine tuning, application specific. So these are different uh, algorithms and models people used. Now, in my last two slides, I'd like to emphasize that there are some misconceptions and misuse of terms which is spreading, which may not be healthy for science and technological advancement. I'll start with the LLMs are assumed as the only AI technique. Now, some may say, no, that's not the case. But if you look at the majority of the literature, everybody say, oh, I used AI. Why I cannot say LLM or whatever that is true. So as I mentioned, pure data-driven AI models are also called LLMs. There are some reputed publications, they did not use language tokens, but they still call it LLM. So Does it matter? Is it, what is in the name? I think that is important. The name should be correct. So there is a recent article from Stanford. They say AI-based system and application, they labeled as AI flaw. Algorithm doesn't have a flaw. It's the system. It is the tool that been developed. So AI flaw, if somebody say, maybe it is catchy, but carries a long message to the future generation. Then data imbalance, algorithmic strategy, the AI bias. All AI algorithms are biased towards certain things because they are guided search. They are approximation of the data. So there may be data issues or the things that appropriate for guiding should be there. If gender should not be used for job search, then gender should not be considered in the algorithm. But if you use a fixed model, there's no way to fix it. And another thing is what GAN model in AI stands for. GAN, majority of the attendees knows is a generative adversarial network. But my argument is that there is nothing adversarial in the equation in the algorithm. A GAN simulates an interaction between two AI models competing based on their defining characteristics, which has wide applications, generating synthetic data, hyper-realistic images, videos, and other transformative code contents. And it can also be used for adversarial purpose. Since somebody first time use generative, we don't have to use the same term. It should be either generative associative network or something similar. Here I have the discriminator and the generator illustrated. I can create many variations. This shows my target. I can create many variations. There's nothing adversarial. So you can see here, there are wide synthetic data, non-adversarial applications. There are some adversarial applications like deepfake and others, but that does not make the GAN should be called as a generative adversarial network. So I'm ending with the summary of my talk. Application specific, smaller AI model should be used and need to have components which can quickly train with curated data to make just-in-time decisions. Pre-trained general-purpose language models are not appropriate for cyber defense as these are static and exploitable. Auto-generated code require attestation and certification on risk level. If I'm using for healthcare, so some attestation is needed and certification. AI in security need trustworthy AI, which can prevent input-output manipulation because AI model can be manipulated. Need data-driven non-LLM AI model for autonomous machine-to-machine, device-to-device decision support system, where language has no play to be here. But to be secure, integrated AI techniques can provide robust and collaborative output because all AI algorithms have their own advantages and disadvantages. So, and more disclosure be needed for independent testing, evaluation, and labeling of AI-based security products and services. Accountability, regulation, and governance are essential for interoperability, explainability of using AI for surveillance, data collection, and automated decision. With that, I have some references, and thanks for listening. Sorry for the initial hiccup. I'm ready to get some questions. I know it got a little longer.
Yeah, thanks, Professor Dasgupta. It was really very insightful. And there are some questions on the chat window. So the first question from RR is, if LLMs cannot reason, can they be sufficiently trustworthy for cybersecurity?
if LLM, what is the question?
LLMs cannot reason. So can we trust them for cybersecurity?
That's what my argument was. We cannot trust LLM if we cannot evaluate independent evaluation, if we don't know what are the scope of the model. And my focus was on generic LLMs. If someone come with application specific LLMs where log analysis, something where human interaction is there, then language may be important. But when machine-to-machine communication and data analysis, data processing, I don't see the reason to use language-based tokens. But again, this misnomers, there are many words which nothing to do with languages, but still people label it as language. Yeah, go ahead. Any other question?
Yeah. How can large language models be used in power systems, and what is the requirement for the LLM to model or detect any attack?
So my point is that there are people, big players who are advocating LLMs for their businesses. My as a 35 years of AI research, I will suggest to form a team of experts, build your own model from the data that whatever that is a power system, SCADA, and train it on your own data. Bigger is not needed. What is needed is the coverage of the data, that problem you are trying to address, application, and all related data, which are curated, which are not scrapped from from the wild. So these are bound to come, and because otherwise safety critical applications cannot succeed with taking something off the shelf. There is no accountability, there is no auditability, there is no third party evaluation, independent evaluation. So that's the concern when these are used in safety critical application.
Okay, and then there are some requests to share your slides.
I thought you recorded it, so that can be shared, or IEEE CIS can also put that on their website. Some of my lectures are there.
Yeah, the recording will be available. So I think that should be sufficient. And the other question that is upvoted by multiple participants is, please suggest some sources to explore this area for the beginners.
I will say start from the scratch, build your own model. Start even if you are selecting the neural network will be your model for experiment, or then build your own neural network. It is not difficult. You can write the code, you can use different transfer function, you can use different loss functions, and see which one works better. What will be needed is the data set that you are working on. And like healthcare have their own data, other industries have their own data, and getting those data, build a prototype and show it works. And then other people will help in getting the data, make it more precise. Because we don't need trillion parameter model for one small applications. You may 1 million or some thousands of parameter may be good enough. So why I will have giant elephant, but if I am only using the leg, one of the small leg, so or tail, so that's the because extra information is always dangerous for safety critical applications.
Yeah. And another question from Nicholas Redmond is, do you think we will see more people training their own models and using them in the context of an edge application? Uh, so would that cause the big companies to be concerned?
I think AI is like any other tools and techniques. So all the software development concerns will always be there. So there have to be a domain expert. There will be a hardcore AI people should be in the team and software development team to build something useful and effective. So I think smaller models are bound to come. Larger model will be used for various, general purpose use, not specific, where general purpose is where accuracy 65% may be good enough. And but when it comes to 99% accuracy, it will be risky for a number of reasons I mentioned.
Okay, and Ambrose is wondering whether these large language models can be used for detecting new viruses or malwares.
Yes, as I mentioned, uh, these are double-edged sword. LLMs can be used to detect, because LLMs are AI model, to detect virus, and also it can be used for spread viruses. So we cannot be blind to see, oh, I'm only doing for defense or protection, but we have to make sure that protection is flexible, adaptable. We have a patent, it's called adaptive multi-factor authentication, where someone need to be authenticated in an dynamic way, not like login password and OTP, which is fixed. There are 100 different ways someone can be passively, actively, combination can be authenticated. So our patent is on that aspect, and it can provide a zero trust authentication. So you can make sure that person is authenticated, and it's a part of continuous authentication. Again, I'm going back, fixed model with pre-trained, with huge amount of data is not necessarily a good tool for narrow application, very specific app. Yes, it gives a good platform to run, but you have to think about the consequences.
Okay, and Daryl Palmer is wondering about documentation. So he says, I have seen some uses of large language models not to generate code, but to automatically create design documents and requirements documents to document systems from source code. So creating documents is an activity that most software engineers don't like doing, but the impact of inserting exploitable defects in design and requirements can cause larger issues than just exploiting generated code. So have you seen any research
Yes,
in
I
this stuff?
think um, creating manuals, creating content, creating text, maybe one of the area have a less risky. But no matter what, the people have to be know what they are doing. Now, writing a story, creating a music, there are tools out there, and other industries will be heavily affected by AI tools, because anything repetitive. anything, can be trained with will be taken over by the AI tools. There's no doubt about it, whether it's LLM or non-LLM. So code generation, story building, a design document, if it can generate, but somebody have to have knowledge to understand. Uh, uh, so that is important too. So if we like entry-level coders are now many companies are there saying we don't need entry-level coders, but you need somebody who can understand that the codes are right. There is no extra loops that can cause damage to the program. If only look at the functionality, not the whole aspects. So if we don't need, if there is no entry-level coder, then who will be in the advanced level coder? So entry level slowly become advanced level. So we'll be losing a lot of uh, talent pool to get trained if they are hooked into these automated systems.
Yeah,
And
I think
people argue that when calculator came, we used calculator. We did not have to do hand calculation. I agree, but up to what level you like to automatize the thing that uh, human will be made fool at the end, because it is a game of intelligence. You can use one kind of AI and do certain things. Another person can use another type of AI to defeat you. So, in early days, I used to give my IEEE lecture when this uh, Deep Blue, IBM Deep Blue defeated the human uh, uh, chess player Kasparov. There's a huge thing that machine can defeat human champion. Yes, but imagine there are million possible paths and which machine can quickly do it. But human may take little more time to think and put it. But if the game policy has changed in the middle or board size has increased, machine cannot do it unless it was trained. Human can somehow handle the issue. So AI or any algorithm has its own limitation and scope that need to be understood building anything.
yeah, I think the human in the loop will prevent a lot of these issues. And there are some questions about the recording. The recording will be available. I will email the registration, whoever registered, I'll send them an email with the recording link. And so there are no other questions, I believe.
I have a question.
Okay,
Go
go
ahead.
Yeah, so in recent discussion with Lucan, he said he doesn't like LLM. And if you look at the recent paper from Apple researchers, they pointed to many flaws in LLM, which makes people wonder why even we care about LLM or we use them. So if we don't, if the future is not LLM, but perhaps better AI, why even bother about LLM security?
That's a valid point. At this point, LLM is a big player in the field, and we non-engineer, non-computer science people are heavily using LLM, and of course, that's the whether how long that will be, because benefits are unlimited. Any field you go, that LLMs can, because it is a language based, and many of the things we do on a language basis. So that's the thing. But LLMs will be there, also AI is not going to go away anymore. What I'm anticipating that more and more smaller specialized models of different AI algorithms will emerge and applied to different areas. What will be benefit then? It will be specific to that application and fine-tuned to get 99.9% accuracy, which is not possible in generalized large language model. Again, my topic today was two aspects. The generalized large language model have some inherent security issues. Number two, is this models are applicable in cybersecurity? Those are the two things. I think cybersecurity need specialized model. Cybersecurity need lean and thin application-specific models where need to know, analyzable, those aspects are there.
So I thought from your presentation, you are looking into security inherent in LLM, right? Because of hallucination or some people embed some wrong information.
As I said, this talk has two aspects: security of LLMs and LLMs in cybersecurity.
So how to use LLM for cybersecurity?
Yes, there are a lot of companies and businesses, and they are using LLM for cybersecurity. At least they are promoting that. How much that has come to reality, yet to see. But my talk has two parts. One is this generic models have inherent issues because it hallucinate in application specific. They are not secure. Code developed by them are also from open source, and that also have some security issues. And then next was the using those LLMs for cybersecurity.
Got it.
Again, I'm available. Anybody wants to communicate, provide any feedback. If someone can point out that this part of my lecture was not accurate, I'll be happy to work. And because I serve as an advisor to several startups and companies, so I'll be willing to talk to them.
Okay. And there's one last question. I think we can quickly answer this and then close the session. So Untung is asking about security token generation. So he's asking what would be the recommendation to address the vulnerability of getting security tokens generated by AI? Is there any vulnerability?
So I'll put it in the general aspects. If you use the existing LLMs for generating security tokens, if you know that LLM is secure, then the token generation may be. If you don't know how it was designed, developed, and tested, independent third-party testing, then security token generation may have some issues, because always there are two sides: people who are using, people who are trying to break. So for whatever the reason. So anything, both sides need to be thought carefully, and one side fit all will not work in cybersecurity domain.
Yeah, I think that should answer the question. So there are a lot of thank yous. So a big thank you from the chapter as well. So as a token of our appreciation, I wanted to present this small certificate to you. If it was in person, we could have done it a little differently, but since it's remote, this is a small certificate. I'll email it to you. And thanks again for a great talk and a great session. And we'll keep in touch.
Thank you. Thank you for inviting me.
Yeah. Thank you, everyone. Thanks for attending. See you in the next event. Bye now.
Thank you very much. Great talk. Thank you.
Yeah.